Good evening, all. Can you hear me? Hello.
Hello.
Yes, sir, we can
Yeah,
hear you.
yeah, yeah. Okay.
Yes.
Yeah. Okay. We'll start this session. So in this session, we will see some. I think. Can you able to see my screen, right? Uh,
Yes, yes.
yeah. Okay. Can you see my lab notebook?
Yes.
Yeah. Okay. Fine. So basically, in this session, we will see some mathematical statistical functions. Okay. So of course, using Python, we will see. Okay. So already you know some basic mathematics, but when it comes to using Python, okay. So data science is majorly you require a knowledge of probability and statistics, right? So we have seen different kinds of probability functions and models using Python. So in this session, we will see the statistical functions, mathematical statistical functions, okay, using Python. Okay, I will do parallelly using my Google Colab. So I hope you can able to see my two screens. One is Colab notebook and another one is the tutorial. Okay, Python tutorial. So basically, the statistics means, okay, of course, you are going to have numerical values or floating point values or any other values, categorical values like that you are going to have. Okay. So what are the major basic statistics? Okay. In mathematics means, of course, mean, median, mode. Okay. So you may have different types of means, different types of modes, different types of medians will be there. We will see one by one. Again, these mean, mode, okay, all these things we can able to apply on different types of data. Okay. So like integer, float, okay, decimal values, sometimes maybe some fractional values. Okay. So this will be different types of varieties of data. So these statistical functions, of course, in Python, as you know, you need to import some third-party libraries such as NumPy and SciPy. So the statistical functions will be there in this NumPy or SciPy. Okay. So for example, if you want to calculate, first we will see simple examples, mean and median, mode. Okay. Then we will move forward. Suppose, just 1 minute. Uh, See, for example, I want to calculate a median value for a particular data. Okay, so of course I am doing some statistics. We need to import. Uh, I want to do median, right? You need to import median function from statistics. Okay, so for that you need to use from. So statistics will be the library. Okay, you can import median. Okay, so if you want to do any median related uh, you want to implement median on your data, you need to import this median function. It will be available in statistics. Okay, from statistics, import median. So at the same time, in real time, you may get different types of data. You may have numericals, floating point data. Yeah, you may have some other decimal data. Okay. Sometimes there is a chance that some missing values, some NaN values also possible. Okay. So what you will do is whenever you are having missing values or NaN values, okay, not a number values, so you need to do some kind of processing. Whether you need to remove that NaN values or you need to clean up that data, or you want to replace that NaN or missing values data with some technique. Okay, like mean, median, mode. Okay, you can use some technique to replace those cells or fields. So for that, uh, you need to use some statistics. Okay. So for example, whenever in your data you are going to have is nan. Okay, is nan means a kind of not a number. If you don't have any number in that field or that attribute, okay, so you need to do some calculations. So in this case, we are doing median. Okay, we will see uh, this nan will be there inside this math library. From math import is nan function. You want to do some manipulations on missing values. Okay, you need to import this is nan. Then you want to clean up your data. For that, you need to import a filter. Okay, filter false data. So you need to import from this will be available in intertools. Okay, intertools will be the one of the package. You can import filter false. Okay, so these are the just execute this cell. Okay, I think there may be iter, not enter, iter tools. Make sure that there will be no typo errors. If you are having any typo errors or any spelling mistakes, the Python cell it will throw some error. You just go through that error and you identify that. Okay. So what I am trying to do is I am trying to create a data. So initially I am taking a simple data. So this is some data, okay. Just I'm giving some values. You just assume that this is maybe a floating point data, like data equal to 20.7, then float. I'm giving different value, okay. So here I am entering my data as nan, okay. So here we are creating the data, but in real time you will get this kind of data from your data set or from your applications, okay. So as of now I am just creating a simple data to demonstrate where you are going to use these statistical functions in your works, okay, using Python. For that purpose I'm creating a simple data. So this is my data equal to 20.7, then float nan. I'm just giving this nan intentionally, okay. So then I'm giving some 19.2, so then 18.3, okay. Again you try to enter some other nan, okay, not a number value. So this is nan, okay. Then you can enter one more value. So this is a data which I have created and it will be stored in this data variable, okay. So just one second, okay. Next what you want to do is, for example, this is my data. There are different values 20.7 and 19.2, 18.3, float and 14.4, something, some data is there. So you want to sort this data. For example, if you want to sort this data, you can able to use, okay, in Python sorted, then you can give data. Generally, if you are having all numerical values, okay, if you give sorted data means it will give the sorted data, okay. So but in this case, whenever you are having this kind of values, okay, nan values, even if you are giving sorted data, it will give some kind of, okay, surprising behavior, okay. So this is not the sorted data, right? Okay, you don't have some 20 is there, nan is there, 14 is there, okay. This is not the data, this is kind of a surprising behavior. So if you are having such kind of things, okay, so for example, by using this data you are trying to compute some median, okay. Let see, if you want to compute median, you just import that median function from statistics library. Median of, you are passing this data, okay. So we will see what is the median, okay. A median means a kind of middle value that will be present inside this data, okay. So if we will give median of something, you will get this output, okay. Actually there is no such value 16.5, okay. So that result is some kind of, this is not, we are not going to expect this kind of result, okay. Median means you are going to get some middle value, or if you are having any kind of even number of values in your data set, okay, it will take that average of those two values, then it will produce it. But in this case, it's giving some unexpected results because of you are having different NaN values, okay. So it is going to compute some wrong things, okay. If you are having such kind of scenarios, then what you want to do is, so you want to make this entire data in a consistent, okay. You need to create a consistent data. So that whenever you are computing this median value, it will give the correct value, okay. So for that purpose, okay, what we are doing is in Python, okay. So there is a function, okay, map function is available to ensure to get a consistent result, okay. So even if you are having your data input is having mixed kind of data inputs, okay, mixed kind of data inputs in the sense you may have integer, floating point values, okay, or decimal values, whatever it is. Even if you are having a collection of mixed types of undefined dependent input variables, okay, like different types of data, you can use this map function to ensure to get the consistent result, okay. So now what we are trying to do is, so if you want to know how many missing values in your data, for example, in this case based on observation, there is two missing values, okay. There are two places NaN values will be there. We can able to say there are two missing values are there because this data set is small. You have only six values. Within that six values, two are missing values, okay. For example, you just assume that in real time you may have thousands, okay, or 100 records, okay, something will be there. In real time data, it may be, you can say it may be thousands or lakhs, okay. So whenever having such kind of data, how do you know how many missing values are there, or how to replace that missing values with some numericals, okay. So it's very difficult to do, okay. You can't able to do manually, right? If you want to do for 1 lakh records, you want to do manually means it will take so much time, okay. Days and days or weeks, months, okay, it will take. So for that purpose, if you want to do such kind of statistics, okay, such kind of computations using Python, okay, it is very easy, okay. So you can prefer these statistical functions that are already existing in Python. You can use these statistical functions to do any kind of data manipulations or to replace any statistics inside your data set. You can do it, okay. So this is your median value. For example, if you want to know how many number of missing values will be there inside this data, so you can write a code, okay. How many number means you need to use, okay, how many means the number of values, okay. For that we are using some function. So inside that you can write map, okay. So you write map, then you can give is nan in the sense means that is where not a number value will present. You are going to give is nan comma data. Your data will be presented in this data variable. You just give those two things inside that map function. You give is nan and data. So then you execute or you run this cell. It will display, okay. Uh, the number of missing values inside this data is 2 because there are two places which is having nan, okay. So like this you can able to know your nan values, okay. So if you want to see any other thing, okay, for example I am giving one more nan here, we will see, okay, what is the result
Uh,
we will get.
yes, sir. So the NaN value is nothing but the null values, right, sir?
Yeah, it's not a number actually. Nan in the sense means
Not a
not a
number.
number.
Okay.
There is no
Okay.
number. Sometimes it may be missing values, sometimes
So
maybe
in
null
the
values.
as you said in real data, so it will be like means the numbers will be blank, so there is no number, right?
Yeah, there will
Instead of
be no
null.
number. Yeah, maybe empty cells will be there. There are fields.
Okay.
Okay. Hmm.
Okay. So we can find it out using this
Yeah,
formula, sir. Map.
you can find out easily by using this kind of statistical functions. Okay. So if you
Yes.
are having small data based on observation, you can able to do it manually. But you just think about you are having large data set. Okay. How you can able to do? You need to apply this kind of statistics,
Yes.
right?
Yes.
Yeah.
Yes.
So now we have, I'm just intentionally creating one more NaN value because we need to know. Okay. Then I'm sorting this one. I'm executing this. So now see, I added one more nan value somewhere. Okay, you can add anywhere. I'm just creating this data set manually, but in real time you may get the data set. Okay. So here it is showing 3. Okay, like this you can able to know this nan. Okay, now what you want to do is your job is whenever you are having, okay, whenever a nan value will comes into picture, if you want to do any kind of analysis, if you do analysis including this nan values, okay, it won't give that much accurate value. So what you want to do, you want to do some cleaning procedure, or you want to do some kind of pre-processing procedure to remove that nan value or to replace that particular field. Okay, wherever that missing value is there, you do some kind of mathematics to replace. Okay, you apply some technique to replace those values. Okay, so for that purpose, now wherever nan is there, you know that you need to clean that particular value. That means in this case, I am trying to remove that particular values. Okay. So because it's giving some kind of odd, okay, unexpected results whenever we are computing median, it's giving some unexpected results. Okay. So you want to clean up that wherever nan is there, you want to clean, okay, that data. So for that purpose, what you want to do is, so we already imported filter false, right? This package with the help of this existing feature in Python. What you will do is you clean that wherever is nan is there, you clean the data. So we are going to write, okay, how clean. You just take whatever your data, clean list filter false. You use this function filter false. Uh, that means you are trying to remove this one. Wherever is nan is there inside your data, you are trying to filter or you are trying to remove that one. Let me see, we are trying to execute it. Okay, yeah, we can able to execute this cell. Then you try to print this screen. Okay, so after executing this filter false function, you see how your data look like. Okay, if you print this clean, okay, I'm giving some meaningful names. Data means your original data, clean means after cleaning, okay, after removing these nan values, how your data look like. Okay, after cleaning, so your data look like, okay, 20.7, then 14 point, okay, here, okay, again I'm telling, okay, previously we applied sorted data, right? So this function we applied. So that's why whatever data, okay, you are trying to sort it out. Whenever we are trying to print sorted data here, we are unable to print the sorted data here because of this nan issue. Now after cleaning this data, you print that cleaned value, you can able to see the sorted data. Okay, so this is how you can able to get your value. Or else if you want to again you want to apply some kind of sorting, okay, either ascending or descending, again use sorted clean. Now you just see, okay, so it will do reverse. Okay, so if this is your data, again you are applying some kind of sorting, you can able to get your data like this. Okay, so if you want to do one more time, we will see, okay, what will happen. So again I am trying to, so what you will do is, for example, this result I am storing in some other variable a, okay, so like this I am trying to sort this thing, we will see what will happen. Okay, I think a is not defined, okay, something. Okay, anyhow, that is not our aim. Our aim is to sort this data. Uh, so this is how you can able to sort your data. So once you sorted your data, I think already you are familiar with this median concept in mathematics. Okay, so whenever you want to compute median, first what you want to do is you need to sort the data. Okay, median means a kind of middle value, right? So after sorting only, you can do, or you can able to calculate that median value. Okay, so now we have sorted, then you apply or you just execute this median function, median of clean. then you can see. Okay, so actually in this example, this is even number of values. Four values are there, 1 2 3 4. Okay, so if you are having odd number of values, okay, you will get that middle odd value will be the your median. If you are having even kind of data, the average of these two values, 18.3 plus 19.2 by 2, so that is our median value. Okay, now if you do 18.3 plus 19.2 by 2 mean, so this will be my median 18.75. So this is how you can get median value whenever you are having um, a data set. Um, in real time also, if you want to do calculate any median values for your data set, you can calculate like this. Okay, so any questions? So if you don't have any questions, we will move further. Okay, so like this. Okay, this is just for median example. So this is the results what we are expecting. This is well-defined results. This is actual results. Okay. So previously we got some unexpected results. This is not correct value. Okay. This will be the correct value. So similarly, so we will see. Okay, the other statistics also. This is median. So I think there are so many statistical functions will be there. We will see few functions. We will see mean. Okay. So already you know what is mean. Okay. What is mean? It will take average. Okay, for example, now I am trying to calculate mean. I am just giving some values, mean of 1 comma 2 comma 3 comma 4 comma 5. Okay, you just try to print just 1 second. I'm just taking 1 2 3 4 5. I'm just trying to print mean of this value. So if you want to, okay, and the issue here is if you want to use, okay, previously for median we imported some package. Okay, so if you want to do use median or mean, you need to import respective package. Okay, here it is showing mean is not defined. Okay, so what you will do is instead of median you take mean. Okay, we will see. Okay, you need to import this package, otherwise it will tell you that mean function is not defined. Okay, like that. Okay, so I imported that respective mean function, which is available in statistics package. So it will return. Okay, generally mean means the general thing is it's a sample arithmetic mean of your data. Okay, whenever mean means it is sample arithmetic mean. What it will do is mean of 1 comma 2 comma 3 comma 4 comma 5 in the sense means it will take sum of that data is going to divided by that the total number of data points. For example, in this case, mean of 1 comma 2 comma 3 comma 4 comma 5 means 1 plus 2 plus 3 plus 4 plus 5 divided by the total number of data points will be 5. Okay, so if you do that calculations, okay, you will get your actual mean. This is my actual mean. That is, you can refer this mean also the average. Okay, so this is I mean. Okay, so in this example we are having positive values. Okay, I mean we will take some negative values. Okay, so inside my mean data set you just take, okay, mean of some negative values. I'm giving minus mean of minus 1 comma 2.5 comma 3.25 5.35. Then you compute your mean. You just check. Okay, again it will take this average of all these things divided by there are four data points. You will get that mean. Okay, so this is simple data set which we created, but in real time what will happen, you are going to get lots of data. For example, you are going to get the data set will be in the form of tabular form. You may have rows and columns. Uh, if you want to compute mean for a particular row, okay, that is the average for a particular row, we just apply the statistical functions for that row. Or if you want to apply, or if you want to compute mean for a particular column or attribute, okay, your data is in tabular form, you can do, okay, this kind of statistics, okay. You just apply this mean function on that particular column or attribute, okay. So this is how you can able to compute mean, okay. So next we will see, okay, sometimes, okay, you may get some kind of fraction values, right? So whenever you are having fractional kind of values, so even for fractional values also you can able to compute mean values for fractional values. So I am trying to give some fractional values like this, okay. Mean of fractional value 3 comma 7, fractional value 1 comma 21, 5 comma 3. I want to compute mean of this one, okay. Then we will see what is the mean of this thing, okay. Again it's showing f is not defined, okay. So whenever it is not defined, in the sense means we did not imported that respective package, okay. Before you want to do any statistical or you want to use any existing functions, statistical existing functions, you need to import, okay. If you want to do any, if you are having any fractional data, I hope you know what is fractional data, like 1 by 2, 1 by 5, 1 by 6, okay, 3 by 7, 4 by 7. This data you are going to call it as fractional data, right? So if you are having that such kind of data, you want to compute mean for fractional data, so you can import this fraction function. So that will be available in the library fractions, okay. From fractions, import fractions as, I'm going to give some alias name as f, okay. So then we are calling, okay, instead of calling the 10 type fraction, what we are doing is, instead of calling the 10 type fraction, we are giving some alias name as f, because this is short form. With the help of this short form, you can able to call easily, okay. F of 3 by 3 comma 7 means this is 3 by 7. F of 1 comma 21 means this is 1 by 21. F of 5 comma 3 means 5 by 3. F of 1 comma 3 means 1 by 3, okay. So we are trying to do I mean we are trying to compute mean for this whenever you are having such kind of fractional values. So you can use this statistical functions. So it's trying to print, okay. So the mean value is fraction of 13 comma 21, okay. So if you are having any doubt, you just do computations using your mobile or calculator. 3 by 7 plus 1 by 21, 5 by 3 plus 1 by 3, you will get a value like this, okay. This is the mean value is like this, okay. So this is other kind of data. I told you, okay, we can apply the statistical functions on different types of data, integer, float, decimal, fractional data. I'm just showing demonstrations for different types or different varieties of data, okay. So this is whenever you are having fractional data, you can do like this. So similarly, you can apply not only mean, you can apply median, mode, something, okay. So next we will see whenever we are having a decimal data. So if you are having a decimal data, so initially we need to import from decimal the respective function, okay, our library you need to import it from decimal, import decimal as d, okay. Again same format, I'm giving some alias name. Then you can give the decimal values, okay. I think decimal means you already know, uh, 0 0.5, 0 0.75, 0 0.25, 0 0.625, 0 0.99, okay. So 0 0.375, all these values we are going to call it as decimal values, mean of. So I called mean of this decimal values, d of 0 0.5, d of 0 0.75, okay. So it will print the mean value as decimal of 0.5625, okay. So like this, whenever you are having any kind of data with the help of the statistical functions, you can apply and you can compute the basic uh, stat, stat, statistics on your data. Okay. So next one is uh, so whenever you are having okay mean okay, so there is a chance that okay, for example, you want to see fractional mean. Okay. So whenever you are having a floating kind of data, you want to compute that mean. Okay, instead of writing f of 3 comma 7 or something like this, if you give some fractional or floating point values. Okay, so you can you want to compute those whenever you are having float kind of values. Okay, or you want to compute your mean in a faster manner. Okay, what you will do is instead of giving this kind of fraction values, you give the values will be 3.5, 4.5, or 7.5 like this. Based on that, you can compute your mean. Okay, so I will tell you. So if you want to compute floating point mean, okay, or flow, whenever you are having float data, you want to compute. Okay, instead of using a normal mean function, okay, this is a simple mean function, right? You can use f mean. Okay, so what this f mean will do means uh, it will again okay, if you want to do f mean, you need to import this f mean function. Okay, um, just import f mean from your statistics. So this will be so you just import that function. You just give okay. What it will do is what is the difference between the uh, first mean and this mean means okay. What actually it will do is it will convert that data to float okay, and then it will compute that arithmetic mean. Okay, so actually it will work a little bit faster than the normal mean function. This f mean it will work little bit faster than the normal mean function. It will always returns okay. Of course, you are calling f mean means it will return the return value also uh, float. Okay, so like this. Okay, so if you are giving any sequence or any attributable values, okay, if your data set is empty or there is something will be there here. Okay, what it will do is it will raise error. That error will be statistics error. Okay, so so that's about f mean. Any questions?
Yes, actually, means what is the means main difference between the F mean and the mean normal mean in terms of
The major difference is the normal mean. What it will do is it will compute okay arithmetics first. Okay, if you are using f mean means what it will do is first it will convert that entire data into floating point values. Okay, for example, in this scenario, I have four right, 3.5 and 4 and 5.25.
okay,
So it will convert. If you are having 4 means it's kind of int value, okay, not float value. So it will convert initially all the data that is present inside the data. It will convert into one particular form, that is float form.
okay,
So then it will do arithmetic computation.
okay, okay. Means we convert all the data into the float form and then
Mm.
it will calculate the
And then it will
mean.
do mean, yeah.
And in normal mean also the calculation
Normal
will be
mean it won't convert, but it will do calculation. The output is same only, but
okay,
you are going to have integer value, float value. Okay, it's very difficult. It is going to if you are converting all data values into one
okay,
particular
okay.
form, then it
So
will be
if
a
you
little
want
bit difficult.
means in general, so we have to do the calculation means like the float values are there, so we can use this, right?
Yeah,
To calculate float values and all.
you can use both mean, f mean. I'm just giving a glimpse. F mean will be a little bit faster. It will run a little bit faster than mean.
Okay,
The
okay. In
output
terms
is
of
same
the
only.
data
Yeah,
size,
yeah,
if the
yeah.
data size is big, then this will be
If the data
faster.
set is big, okay, you are going to have float and numerical values. You want to reduce your computational cost, okay, something like that, okay. You want to run your missions in a fast manner. You can use the concern static functions. It can do fast manner, okay. Maybe we are having few data points. We can't able to see. I mean that whether it is running faster or slow. But if you are having larger data set, then that time this kind of functions will be useful. Okay. Mm. Similarly, this is for only for one data. For example, you are having two different kinds of data. Like you may assume that like some grades. Okay. For example, a professor. I'm just giving one example. A professor assigns a grade for a course by weighting the quiz marks. Okay, there will be 20% for quiz and homework for 20 marks. Okay, midterm exam like some split of marks will be there. Midterm for 30%, final exam for 30%. Okay, so if you are having such kind of scenarios, okay, so how we can assign his grades? Okay, he will give weights to that percentages. Like okay, I will show you. For example, we are having grades data. Grade will be some grades data will be there 85, 92. Some value grade values will be there 91. Then what you want to do? You want to assign weights. Okay, that is for quiz 20% weight means some kind of weightage he is giving for different components or different assessments. Weights 0.20. Again for homework 0.20. Then midterm exam 0.30. Then final exam 0.30. Okay, so like this we have some data grades and that weightage. So if you want to compute f mean, what is that mean? Okay, mean of that entire class or mean of that grades. Okay, you just call that f mean. Then you pass that two values grades and weights. Okay, you pass these two values, you will get uh, f mean takes one positional argument grades weights. Uh, Again, okay, you just wait. Mm, There is another 85, 92, 83, comma 91. Weights WEGHTS weights. F mean grades, comma. Uh, F mean takes one positional argument, but two are given. So, just,
Sir, excuse me, sir.
Yeah,
Background, some sound is there, sir.
sound is coming. Yeah. Mm,
Yes, sir. Thank you, sir. Thank you very
yeah, yeah.
much.
Is it clear now?
Yes, sir. It is clear, sir.
Yeah, yeah, okay, okay. Uh, uh, can you please check this? Okay, I'm trying to pause two arguments for this F main. It is telling F min is taking one positional argument, but two are given. So, so actually, if you are having this kind of data, uh, so actually, in this, I think we are trying to print directly that weighted mean or weighted sum. Okay, so that's why we are getting some error. Okay, so if you want to compute, okay, based on that grades, uh, suppose a professor, can you able to see my screen? Can you see my screen, right? Yeah. Suppose if professor is giving some weightage for these grades, okay, then what you want to do is first you want to take sum up of that grade into that particular weight value. Similarly, it will take for all these values, okay. So then we can take that weighted sum by sum of weights, okay. So you will get some kind of weighted mean value, okay. So this is another way if you want to print F mean. So, so what we will do is there are different ways you can able to compute this mean values. So actually, if you are trying to print this f mean of whenever you are having grades and weights, we are getting some error. So what we will do is we are trying to calculate that weighted sum, okay, or weighted mean. Based on that, you use this f mean function, okay. We try to execute, okay. We will see whether we are getting same value or not. Okay. So okay, these are different ways you can able to compute that f mean value. Okay. Then
Yes, can we do like means here, like as we mentioned in the query, we
mm,
can just a minute. Sorry. So in this scenario, like grades, so we have four values, right? So
yeah,
in that
yeah,
four values, we can take a mean first of that grade, and then later on we can do the mean of weight also, and
yeah,
then
we
later
can
on we
do,
can
yeah,
divide it.
yeah, we can do like that also. We can divide and we can print. There are different ways. Okay. Uh, so once this f mean is over, then we will move to the next one is geometric mean. Okay. So I think you already know geometric mean. Okay. So what this geometric mean will do means initially it will convert the data into float data. Then after that it will apply that geometric mean. Okay. So basically, what is this geometrical mean indicates that wherever that central tendency or a typical value of the data using that particular data values or products. Okay, so it will take, for example, I want to compute geometric mean for we will see just giving before we want to use geometric mean. I think we need to import. If you want to compute any geometric mean, you need to import respective. So we are trying to import that respective library geometric mean. Okay. So then you can call this geometric function. Okay. So just so if you want to see round off value, you can call round off. Otherwise, we will see uh, geometric mean of three values. Okay, 54, 24, and 36. Okay. So you no need to do anything. Okay, you just use that existing function which is available in Python. Geometric mean of you pass your data set here. In this case, I have given three values, but in real time, instead of giving these values, you just pass your data set here. It will give that geometric value. Okay. So, for example, you don't want this many number of floating point values. Okay. Then you can use other function round. Okay. You want to see your data in within one fractional point. Okay. Just mention one fractional point or two fractional points like this. Okay. So this is this one. So this is how you can do geometric mean. Okay. Similarly, you can do.
Can you just repeat once again about this geometrical means? So what is the main difference between the both and where we calculate this geometric mean function?
Uh, you you already know arithmetic mean, right? It
Yes.
will get sum of that particular value. Okay. So whenever you are having this geometrical mean, okay, so it will indicate that central tendency or typical value of that particular data. Okay, using those values. Okay. So I don't know whether you know this geometric mean math formula. So our interest is not about to know about this geometric mean value formula. I'm just showing this geometric mean will be available in Python. If you want to compute or if you want to use this geometric mean, you just import that existing library which is available in Python. You call that respective function. So have you seen my screen?
Yes, yes.
So this is okay. This is how geometric mean will, a typical geometric mean will look like. For example, this is x1, x2, x3 up to so on xn, right? These are different data values. Okay, x1, x2, x3, xn. So if you want to compute geometric mean, square root of those values, product of this particular values, then n will be the number of values. Okay, if you are having three values, then 3 square root of those three values. Okay, you get your geometric
Yes.
value. Have you got? This is just a mathematical formula. If you are having three values, for example, I have 1, 2, 3. I want to know the geometric mean of 1, 2, 3. So then your x1 will be 1, x2 will be 2, then x3 will be 3. 1 into 2 into 3 divided by, okay, you are going to get cube root of 1 into 2 into 3. Whatever the value you will get, that will be the geometric mean for that particular three values. Okay, so that is how a geometric mean will look like. Okay, similarly harmonic mean. So you want to know more about those mathematical formulas. Okay, so you just go through those formulas, arithmetic mean, geometric mean, harmonic mean. Okay, so what I am trying to convey here is in this session, so there are statistical functions will be available in Python in statistics package. You just import that respective package, you apply on your data or on your data set, you compute that respective statistics from your data set. Okay, so that is the intention. We are not discussing the math behind what is geometric mean, what is arithmetic mean or harmonic mean. Okay, if you want to know more about, you just go to it. Okay, you go through Google or any mathematics book and there will be that formulas and explanation will be available. Okay, so the next one, similarly, if you want to compute harmonic mean, okay, you just try for harmonic mean. You take any data set, okay, you try for harmonic mean data. Okay, I told geometric mean. You just do take 1 or 2 minutes time. You try to execute harmonic mean, and if you want to refer or if you want to verify, cross verify whether you are getting proper results or not, then you can identify formula for harmonic mean in Google. You try to place your values there. You try to compute those values manually and check whether your Python code is giving correct value. It is matching. Okay, your manual computation and Python code both are matching or not. Okay, you just take 2 minutes time, you compute it and you do it. Okay, so this, just try that exercise. Okay. some task. Okay, have you done harmonic mean? Okay, next we will see. Okay, previously we have seen median, right? Now we will see median low, median high. Okay, what is uh, median low? What is median high and all? Okay. Now come to here. What is median low? Okay. For example, I have three data values. Okay, like 135. I want to compute median of low comma 1 comma 3 comma 5. You just try to execute this one. Mm, Again, if you want to do, you need to import respective package. That is the respective thing. You just import that median low function here. See, median of low. Okay, we have three data points, 1 comma 3 comma 5. So maybe in this case, okay, what is the median for these three values? Means 1 comma 3 comma 5. Median is 3. I mean median is 3. Even median low also 3 only. Okay, but I will tell you one example. So we will take the same example. I am going to add one more value. Okay, that is 1 comma 3 comma 5 comma 7. So what is the median for this? For this 1 comma 3 comma 5 comma 7. Generally, median means it will be, you need to keep these values in sorting order. 1 comma 3 comma 5. Already the values are in sorting order. Then 3 plus 5 divided by 2, because you are having even number of values. So there is no middle value. If you don't have any middle value, you need to take average of these two middle values. Okay, 3 plus 5 by 2, you will get 4. Okay, if you want to know, you just give that, you call that median function and see what is that median. So here median is 4, but you want to know what is the low value. Okay, median low. If you give median of low, then what it will give? It will take the minimum value. Low means the wherever that we have two values, two middle values. In this case, 3 will be the low value. It will take that one. Okay. Similarly, if you want to know high, median high value, you just give median underscore high. Then it will give 5. Okay, actually these two are my middle values. Low means it will give 3, high means it will give 5. But if you take previous example, only you have one value. Whether you call median low or you call, you will see. Okay, median high, you are going to get the same value only. So in this case, whether you call median underscore low, median underscore high, okay, whatever you will call, you will get the same value. But when it comes to here, you are having two values. It will take the lower value as median low. It will take the higher value as median high. Okay. So there are scenarios you can able to do statistics like this. Okay. Such cases, this median underscore high function and low function, it will be useful. Okay. Then if you are having, I mean, grouped data, grouped data in the sense means same data, it will repeat it. Okay. For example, so there is a grouped data, same data may be there, like 2, like that. One particular value it will repeat some number of times. So for example, I want to compute this 52 comma 52 comma. Previously, all your data points are some kind of different data points. Okay, now in this case, your data points is it's a kind of continuous data, 52, 52, 52, 52, like this. You will get a continuous data points. So if you are having such kind of data, again you need to see. You just import the thing. Stop. Just give grouped. Okay, from statistics we are trying to import median grouped function. So the value will be whenever you are having these two are continuous data. Even though if you are having this kind of data, it will arrange in sorting order. Then it will take the average of these two. You will get the grouped data output as 52.5. Okay, so we will see another example for another grouped data. Okay, for example, a kind of grouped data, it is repeating many number of times. Okay, so if you are having a grouped data like this, 1 comma 2 comma 2 comma 3 comma 4 comma 4 comma, like this is one group, another group, another group. Okay, another group, one group, second group, third group, fourth group, fifth group. Okay, so this is median for this particular grouped data. For example, I just removed that grouped. Okay, instead of grouping, if you give median, then see the result will be 4, because it will directly take. Okay, what it will do means it will directly take the middle value. Okay, here we have 4 values, this side we have 4 values. Okay, it will remove those 4 values and it will take that middle values. Okay, so if you give grouped data, then based on that group it will compute that medians. Okay, so this is another example, median by using. Okay, similarly, mean is over and median is over. We will see for mode. Okay, so I think you already know basic thing. What is mode in the sense means mode is a kind of unique thing. Okay, so for example, there are some scenarios, a particular categorical attributes will repeat number of times. For example, you may have a data set um, called, okay, you are going for a particular course, okay, BTech course or something, for 2 different sections. Okay, you just assume that. Okay, uh, A section, B section, C section, or like this different sections you are going for to take a course. Okay, so sometimes you want to compute a kind of mode values. Okay, based on section. Okay, you are going to have grades, all your grades, all your section grades are combined file is there. You want to compute mode value. Okay, in such scenarios, so mode is the number of times a particular section is repeating. You just take that as mode. Okay, so mode is nothing but the multiple. Okay, again, okay, mode means a unique mode is there, multiple mode is there. Okay, the number of times it is repeating in package. Again, package we need to import from statistics, import statistics, import mode. See, uh, this is my different values. I have given this color, okay, red color, blue color, red, green, red, red. So mode means the number of times a particular value it is repeating, okay, that will be the your mode value. He in this case, red is repeating 4 times, okay, so it will take red as this particular mode, okay. So any questions? So this is a kind of non-numerical data. Actually, this is called categorical data. If you want, you can apply this for numerical data also. Similarly, multi-mode. Whenever you are having a multi-mode, okay. So you want to compute multi-mode data, you can able to compute. Uh, the next one we will see. The next function, the next statistical function we will see is as PS, okay, some kind of, okay, there are some functions which will calculate, okay, how much population or sample tends to deviate from the typical average values, like that. If you want to compute something, okay, so there are few functions will be available, okay, like PST, like this is population standard deviation, that is PS ST deviation, okay. So if you want to use PST deviation, so what it will do is this particular function, this is population standard deviation, okay. If you give a particular values, okay, it will return a value, we will see left line, population, you need to import again that respective function PSTV deviation. I think there is some typo. PST, you just import that package, then yes sir, I'm in lab sir, shall we go? Yeah, okay, okay, I will end this session, maybe within 10 minutes. Can I come by 10 minutes? Okay, we will go by walk. We will go by walk. Okay, sir, okay. Hmm. Yeah, okay, okay. Fine, sir. Hmm. Ah, ah. Hmm. Okay, okay, sir. Hmm. Okay, then you try to apply this population standard deviation, okay. So for a particular data values like this, okay, then you see what is the outcome of this one. Okay, so this is a kind of population standard deviation. Okay, similarly variance is there, the direct functions. Okay, if you want to compute uh, variance, okay, you can able to compute. Okay, so generally uh, after
So we
mean,
can calculate the standard deviation by using this particular formula, right? For any population.
this is population standard deviation. If you remove p, if you use only standard deviation, then you can able to compute. This particular function is different, whatever I showed. I will show you another function that is only for standard deviation. Can you see my screen, right? ST deviation,
Yes, yes,
sample
yes.
standard deviation. Okay, this is different actually. If you want to more explanation, I
So
think
in some,
I will. Hmm,
yes. So in
yeah,
some
I will.
data set, they are asking for standard deviation. So we can use this formula to get the
Yeah,
standard
yeah.
deviation.
You can use this function to get that standard deviation for that data. I shared this link. Okay. This docs.python.org. Here you may have so many statistics functions. If you want more explanation about this math, okay, these functions, okay, you go through that one. You try to practice parallelly because they have just gave that theoretical things. You just practice uh, executing with simple examples. After that, you try to apply these functions on your data set. Okay, so that will be more useful. Similarly, this is population standard deviation and population variance of data. Then normal standard deviation will be there, variance will be there. Okay. Again, okay, this standard deviation, these all are mathematics. Okay, already a kind of formulas will be there. If you don't know what is standard deviation, what you will do? You just go through and learn from some mathematic books, or you just Google it. You will get some formula. Okay, so this is standard deviation will look like. Okay, x x minus x bar means this is mean value. Okay, summation of those two things by n minus 1, square root of something. Okay, that is your standard deviation. Okay, so similarly, if you want to know what is variance, okay, you just type and you just get familiar with that formulas. If you want to use the same things in Python, you need to import that respective functions and you need to use those things. Okay, so these are geometric mean, harmonic mean, mean, median, mode, okay, standard deviation, variance, all those things will be there. So what I am trying to do is, uh, I am interested in, we'll see some more functions which we didn't covered. Covariance, okay. So I think all of you know covariance means you may get two particular, okay. There will be two inputs will be there, x and y, okay. You want to measure covariance of that x and y, okay. So in such cases, okay, um, I will tell you, we will see with the help of one example. Covariance we will see. So I am importing that covariance function. Then I am giving some values, okay. You are giving two inputs and you want to know what is that covariance. You just give some values, okay, 1 comma 2 comma 3 comma 1 comma 2 comma 3 comma 4 comma 5 comma 6. Similarly, you give some y value. Uh, like if you want, you can give same values also, no issue. 1 comma 2 comma 3 comma 4 comma 5 6. Okay. Then what you want to? You are interested in covariance of uh, So you are interested in covariance of x comma y. Okay. See, like this, these are two different inputs. In this case, I have given these values. X will be these values, y will be these values. If you give covariance of what is that x comma y, you will get this one. Okay. Suppose if you have another, okay, there may be another input is there. You want to know, let us assume that that is z. Okay. Some other input is there. It will be like this: 5 comma 7 comma 6 comma 4 comma 9. You want to know what is the covariance between x comma z or y comma z. Okay. In such cases, you can call, okay, instead of calling x and y, you may call, you want to know x comma z. Okay. You just call x comma z. Wait. Uh, covariance.
So values are 5 and 6 actually. So Z values are 5 actually.
Yeah,
So I,
Z value. 5, 7, 6. I need to add one more value. We'll add something, okay. So this is, okay, covariance of uh, like this, okay, like this you will get covariance, okay. Similarly, we have correlation
so for what
sometimes.
covariance indicate means actually, because I know the things, but yes, covariance how we can means what indicating the covariance of both, like means from output we can what can we can judge.
Uh, what we can judge in the sense means, for example, you
And
want to know a
take,
relationship between the two variables or something, okay. You have two inputs. You want to know some kind of measurement of relationship, okay.
so
You
it's
just
kind of like that means it's compare between 0 to 1, and if the value is near to 1 it's mostly related, and from 0 it's not related, kind of.
basically x will have some values, y will have some values, right? You want to know that change, the variable change. For example, x is having 1, y is having 2. Just assume that how much change it is there. There is a one change. That means variance. How much variance is there between x and y? Are you getting my point? It's kind of
Yes,
a
yes, yes.
relationship measurement between two values. For example, I have x value as 1, y value as 5. What is that variance? 1 to 5. There will be some 4 variance is there. If you are taking only single numerical data, 4 is there. But you are going to have x data as a set of data points, data values. Y is another set of data points. You want to know how much variance will be there or what is the relationship or measurement for these values, okay? So that is the covariance. If you change a
Yes.
particular value, if you change a particular input, it will impact the variance value, okay, the variance output also.
So it defines X caused Y to change, or Y caused X to change, or something else.
Yeah, yeah. Both are some kind of, you want to know some relationship between these two things. If you change any data points in X or Y, of course your covariance, there will be some change will be there. Okay. Um, Anyhow, if you want more details, okay, you can find this mathematics. Okay. Okay. So with this knowledge, I shared this link, okay, this Python tutorial link in this G chart. You try to go through and you explore different types of statistical functions will be available. And you try to practice those functions. You will get some knowledge that about that mathematical statistics. You can apply that knowledge into your projects or works or on your data sets. Okay. I'm trying to end this session. Okay. Uh, Thank you. Good night, all. If you are having any questions, is there any question? Otherwise, I will end this session. Okay.
Hi, I just have one query. Last class you started that Titanic
Yeah,
question
yeah.
about
I think
cable.
at that time I didn't get proper internet. Actually, I'm outside. I will be there in northern part of India. Anyhow, I will try to make video again. I will record and I will keep that link in that live session. I think you can able to access those uh, our live interactions, right? I will
Like
upload my
the
video
one on the
into
YouTube, you will upload it to YouTube
yeah,
or
yeah, yeah. My YouTube channel. I will upload it and I will share that link.
okay.
In your coursework also there is some
Right,
specific
right,
tab is there live interaction.
right.
We just give me some 2 3 days time. I will do that task. Okay, because at that time I don't have internet connection. There is some issue, is the technical issue. I will try
Okay,
to finish it by this weekend. Okay.
okay. Yeah,
Yeah.
thank you for the session.
Okay. Okay. Thank you. Thank you all. Bye.
Thank you, sir. Thank you.
Hmm.